My name's Trey Whitehurst. I'm with a company called CH Whitehurst Solutions. It's my company. I am by trade a lighting designer. What I do is I go into commercial buildings and industrial buildings, and I design lights, upgrade them to LED, or increase the efficiency of lighting, or change the color, or people want to upgrade the look, and that's kind of where I have made my bread and butter. I grew up in the Clemson area. My dad was a teacher there. I got two boys that went to Clemson. I went to Clemson, graduated engineering, so I got an engineering outlook on stuff. And then my oldest graduated several years ago. My youngest about to graduate in December. What I'm here today about is that during the COVID period, when kind of the economy all shut down, I got involved with one of my suppliers, and we started looking at different options with COVID and what was out there to help to alleviate it. And we did research on all sorts of stuff. I've looked at bipolar ionization. I've looked at hydroxyl generators. We looked at ozone generators. And one of the things we looked at was UVC light. And come to find out, that had been around for a long, long time. They were using this back in the 30s, actually, and extensively in the 50s. And so what we found in studying is that it's a very economical way to get rid of COVID and a bunch of other stuff. The problem we saw is it's been kind of held inside of an operating room because it's a medical device, and thus being a medical device, it's extremely expensive. But from the standpoint of a lighting manufacturer, it's a light fixture. It's just a light fixture. It's all about producing the wavelength of light out of a lamp, and how do you put that in a fixture. And so what we came up with is a solution that was not going to cost a fortune to do, a low-cost solution that can do the exact same thing as the high-cost ones, just not costing the hospitals a fortune to do it. Oh yeah, bacteria, viruses, mold, all these type of things. And this was first discovered that light had an effect on this in 1877. 1935 was the first real successful test of UVC light, and they did it at Duke University, as interesting as that is, and they were doing with wound care with patients, and they saw we went from 11% rate of infection from wound care patients to 0.24. And Duke University was so impressed with it, they took this and they installed it in all the hospitals. And this was the upper room stuff, which would be the stuff that's designed to kill the air. This is not even the surface stuff that you see now in hospitals, but it's the stuff that's floating in the air that it's killing. UVC or UV light is on the spectrum. And the spectrum, if you look at the visible light that we look at, it's about between 400 nanometers to 800. That's where we see. If you go below that, you go to ultraviolet, then you go to X-ray and gamma rays. And if you go above it, you get up to infrared and then radio waves and broadcast waves. So there's a whole giant spectrum. What we see is a very small portion of that. Ultraviolet is right below where we can see. So it's not a light you can actually see. A lot of ultraviolet light is reflected off in the atmosphere. All the UVC light, UV is divided into three categories, A, B, and C. A and B can reach the Earth's surface, C can't, okay? A and B is what you get a sunburn from, okay? C is what is killing everything in these viruses and molds and mildews. It's a very powerful light, and that's what they have discovered that kills these things. It has to do with the particular frequency of the wavelength. The C is about, if you know the wavelengths, about 200 to 280 wavelength. In there, that particular wavelength disrupts the RNA inside of viruses. So it technically doesn't kill, you deactivate. Okay, so the virus can no longer reproduce. It's basically non-functioning. At the higher, the longer wavelengths that get up to 280 or above, they have some effect, but the time it takes to do it is very long. So you go outside, you don't see a lot of mold and mildew growing out in the sunlight. Okay, it's because it's constantly on there. Okay, so it does help in that sense as well, but not as quickly. If you're trying to do something in a confined space and you want to kill a virus, you don't need to be able to expose it for 4 days to kill it. You want something that kills it in a few seconds, and that's what UVC does. And it's particularly UVC at a wavelength of 254. That's the most dangerous to any virus or bacteria or mold. What we have is we have three different products. We have what we call air. Okay, the product line is Safe Lume is the product line. We have a Safe Lume Air, which would be mounted at 7 feet above in a room, and it would clean the air in that room. We have a Safe Lume that would be a surface, and what this does is you can take it across and put it right in front of anything in the surface and kill something immediately. If you wanted to do something like a keyboard, something that was, or a phone or something like that, that you could, it's like a giant wand. And then we have a room unit that's designed to clean surfaces and air in an entire room. Now, in that situation, you would want to be in the room when it was going on, which we have a bunch of ways to protect you from that, and that sort of thing. But those are the three product lines. Where we're focusing our attention, now we've done this in schools, we've done it in churches, we've done it in restaurants, we've done it in hospitals, we've done it in assisted living facilities, we've done it in lots of things. But where we're going to target mostly is going to be hospitals and assisted living centers is kind of where we're focused. And one of the things that we've discovered through the research on this is that for hospitals in a patient room, right now, the cleanest place they have in a hospital is the operating room, okay? And they have standards for how many air changes per hour they have to do in a hospital room. And they've just been up from 15 to 20 air changes per hour. So in a hospital room, and your audience will understand what's going on there, is that you've got to move that air changes through that hospital operating room at a very high rate to keep bacteria and viruses out of there. We can get the same effect of the same number of air changes in a patient room by installing an upper room unit. And we've got tons of scientific data to back this up. So you could take the air inside of a patient room and make it as clean as the air inside of an operating room at a fraction of the cost. So now you're looking at a way to save on HAIs, the hospital-associated infections, all those type things going on, and it's happening 24/7. So we're very excited about that. We're working with a hospital locally on it. They're doing testing on it. We've installed it in hospitals in other parts of the country with phenomenal results. So everyone's very excited about it, and what we're trying to do is figure out, okay, how do we get this message to hospitals? One of the things that I've discovered in talking with hospitals is a lot of them will say, oh, yeah, we use that in the operating room, and they refer to the little tower units that go around, and they'll say, oh, it only cleans surfaces. It doesn't clean air. Well, what's interesting to me is that originally the technology was designed to clean air. That's where all the discoveries was made. Surface came along later, and yes, it does kill surfaces, but it's most highly effective actually killing stuff in the air. It's just that people don't know because they've only seen it presented to them one way. Right. What's interesting about it is that this was extensively used in the 50s. And what happened in the late 50s and 60s, the pharmaceutical companies started coming along and coming up with drugs. They say, we've got vaccines and penicillins and stuff like that. And so this kind of got phased out. Well, what we've seen now is we've seen drugs that are more highly resistant to these bacteria and viruses. And so now there's kind of a resurgence of this technology because nothing that's on the Earth's surface can ever develop a resistance to UVC because it's not exposed to it on a regular basis. It doesn't ever reach the Earth's surface. We have to create this wavelength. So it's not like a virus over time can mutate to say, okay, I can avoid that. I mean, there's plenty of products out there that do stuff, and the problem we run into now is there's lots of people making lots of claims. And people go out there and say, oh, I can do this and I can do that. And I've run across some of these units that they're standalone units, and they say, oh, we can do all this stuff. But when you really put out and test it, maybe you can't get the air changes they claim, or they tested inside of a shoebox, which is one company did. What we've got, and what excites me about this is there's 80 years of peer review research on this, over and over and over, reconfirming in every scenario. I just looked at a study the other day, and that was specifically for hospital rooms, patient rooms, and by having an upper room unit in there, how much it dropped everything down like 40, 50, 80%. And this was studies done over a year period of time. So there's a lot of studies behind it that say, okay, this technology works. And the thing that's interesting, the CDC has been pulled into a lot of this stuff because there's so many things out there that don't work, that have been advertised to work, even in the UVC world. You know, there are products out there that you can buy on the internet that are UVC, but they're so weak, they don't do anything. You know, or they'll say, I had a project I was working on in Florida with a company. We were designing a facility for a place, and he had gotten these fixtures, and they were told to him, oh, these are antibacterial, antivirus, you need to install these. And he spent all this money buying these fixtures. He comes to me as a lighting designer and says, I want you to install these in my facility. And I'm like, well, let me see the specs. I'm interested. So I saw the specs on it, and I looked at the light, and the wavelength was 395. Now, that doesn't mean a lot to you, but what it is, it's a black light. It's literally the black light you put on your poster. It had no effect on any viruses or anything, but this guy was told by the company, oh, it does. So what's happened is the CDC has started to clean up some of this and come down on these people and say, here's what we recommend, and all these other technologies are unproven, untested, unverified, and what they've come down on is UVC works. It is the one that's only the longest track record. There's no question about what it does. And it's not something that we're recommending in the home. Obviously, people can do what they want to. We're not selling it as a home product. It's a commercial product. And it's because you shouldn't be staring at the light. It's got to be the particular product for, like, particularly in the upper room unit, that the light's exposed out there. It has to be commissioned. Okay, there's products out there that are sold, and they say, oh, just go buy it and put it wherever you want to. The particular product we've developed, and we've worked with UL for years. Every time we make a light fixture, we work with UL. We went beyond just a regular certified electrical rating. There is an EIC rating that's a 62471, I think is the number, and it's a photobiologically tested product. So what we've done, we went to UL and had UL test it. So what happens is when you put this product up there, when we commission it, which we go in after it's installed and verify with all the points on there according to the requirements of this certification, verify that now that thing has been installed in accordance with the UL rating. Now you have a product that is certified safe. So what does that do? Well, that protects the hospital or the assisted living or the commercial facility, whatever it is, from liability issues. Because now someone can't say, oh, I was radiated by this or that. And said, no, that's already UL certified safe as installed. And that's part of the commissioning process. And that's one of the differences in what we're doing. It's not just some product we put together and throw it out there and go, oh, go throw it up. It has to be done correctly. There's also some stuff that needs to be looked at as to where you put it in a room. You need to have someone that understands a little bit about lighting, or a lot about lighting, hopefully, that can say, here's the right location to put this, and here's the right height to make sure it's commissioned properly. So, yeah, it's not something we recommend someone go do in their home. They can contact me directly. You can go to safeloom.net. That's our website. There's some information that you can fill out. I have a contact number you can call me on. I'll be happy to talk to anybody about it and see if we're a right fit for their facility or what they're looking at. Thanks. I've enjoyed it.